Good afternoon, one and all. So we are going to start with the last lecture session for Module 3. This is the hybrid and electric vehicle elective. There is a core elective, professional elective, and there is a third module which is called as energy storage and regeneration. Remaining two modules, what we find is comparatively smaller. So we are almost through with the bigger and more difficult part of it. Now, next two topics what we are having will be more like block diagram representation and explanation of bigger systems. So what we are going to see today is, so there are mainly two topics. One is the concluding part of regenerative braking. So what are the main two types of braking are there that we are going to see today. So and whatever was the remaining part of battery. So that is a battery management system. I have already uploaded some 7 websites, and I requested you to go through all the websites. And a very good another website I have found. It is from a professor, Dr. Gregory. So if you check his website, you might find a lot of algorithms and all these things which are designed. Software is given, so you can design your own battery management system. So all the links and other things I'll be posting you today after this session. So this is lecture number 23, and we are going to finish the module number 3 with this lecture today. So let us see the brake system for EV, HEV, and FCV. Regenerative braking in EV, HEV, FCV introduces slight complexity to the braking system design, and there are mainly coming two questions. First question is how to distribute the total required braking forces among regenerative braking and frictional braking to recover as much as braking energy as possible. So there are mainly two types of braking. One is the mechanical braking, which is mainly used to stop the car. This is called as frictional braking as well. This is the traditional kind of braking which has been there for all the cars since long. And the second one is actually called as the regenerative braking. So regenerative braking is regenerating some energy and feeding it back to the power source, that is the battery. So whenever we are talking about EV, HEV, FCV, in this case there are mainly two issues. One is how to brake the car, how to stop the car by friction thing, and second thing how to generate some or regenerate some energy and feed it back to the supply. So these are the mainly two questions. So second question is how to distribute the total braking forces on the front and rear axles to achieve stable braking performance. So this is another big question, because as soon as we are putting some brake in the front brake, and if all the brake is not synchronized at that time, there is a possibility that the back side of the car will come in a circling motion, and the car will be having some kind of accident. So I told you initially there are two things. One is anti-lock braking system, another is traction control system, so ABS and TRC. So these are the two things you have to start preparing, and also you have to start making groups. So the activity thing will be defined within this week. Activity and OBA, all these things will be defined this week. So for activity, you have to prepare a group of 2 students, and you have to send me their USN and their name. Okay, so every group will be having 2 students. So there are 84 students, so we'll be having around 42 groups, and we'll be having seminar on that. Topics, sources I'll be giving you, and please send me the name of 2 student group wise, so their name and USN. So there we'll be finding ABS, traction control system, TRC, and all those things. So the main problem is whenever we are putting brake forces on front and rear axles, we have to see that, or we have to ensure that the brake force is equally applied to all the front and rear wheels. Usually regenerative braking is effective only for the drive axles. Okay, the front axles are generally called as drive axle. So regenerative braking is mainly happening from the front of the car. The electric motor must be controlled to produce the proper amount of braking force to recover as much braking energy as possible. Also, we have seen last day that if the vehicle is within a certain range, that is around 20-25 up to 45-50 kilometer per hour, then only we can have maximum amount of regenerative energy back we can generate from the regenerative braking. So not at all vehicle speed we can generate good amount of regenerative energy, only in a certain range, that is 15-20 up to 45-50 kilometer per hour we can get best regeneration possible. So these are the small details which will help us. Also, total braking force must be sufficient to meet the vehicle deceleration commanded by the driver. So a driver is pressing the brake pedal. So today we will be seeing two types of braking that is applied in the vehicle. So the initiation is done by the driver. He is pressing the brake pedal. So there is mainly three pedals, three controls that is there at our leg while we are driving the car. So one is the left side is the clutch, center is the brake, and right side is the acceleration. And clutch and gear. Okay, gear is there in generally in the left hand because we are right hand side drive. So clutch and gear, they are actually connected. So before we change gear, we have to press the clutch completely and then we change the gear. So the second control, that is the middle control, is actually for brake. Also total braking, we have to ensure that the total brake must be sufficient to meet the vehicle deceleration and commanded by the driver. So two configurations. So these two configurations we are going to see today. Two configurations of hybrid brake system are discussed next with their corresponding design and control principles. So I have shown you the schematic diagram as may be found in the book and their special features. So one is a parallel hybrid brake system, which has a simple structure and control and returns all the major components of the conventional brake. So this parallel thing is almost like the conventional brake system. Other one is the fully controlled hybrid brake system. Okay, so this is called as HBS, which can fully control the braking force, for which individual wheel, and thus greatly enhancing the vehicle's braking performance on all types of roads. So the second type, so first type is parallel, which is not very smart. The second type, that is a fully controlled hybrid brake system. This is having more number of sensors everywhere the sensor is fitted, and this fully controlled hybrid brake system is the latest braking system which is found with EV, HEV, and FCV. So this is the first type. I think the image is a little faint, but you will find it in book properly. So this is a simple system. There is a parallel hybrid brake system. This is a system which is closest to the conventional and the pure mechanical brakes. So mechanical brakes can be again of two type. It can be hydraulic, it can be pneumatic. Okay, so this is the first type. There is a parallel hybrid brake system. So this system retains all the major components of conventional mechanical brakes and adds electric braking directly on the front axle. So in the front axle, what we are finding is there is a brake caliper, there is a brake plate, and there is the axle. And what are the different sensors that we are having? So whenever you are writing about it, so this can be asked as a 10 marks question. So you can see all these blocks you have to explain properly while you are explaining this parallel hybrid brake system. So first is the motor and the controller. Then there is energy storage. So energy storage can be battery, motor and controller. So there's an electrical motor because we are talking about electric vehicle. Then there is a vehicle controller. So vehicle controller can be there are different attitude and uh, kind of a dynamics control for a vehicle. All these things are coming in the vehicle controller. Okay, so that can be speed, that can be acceleration sensing, that can be that muff, that is whatever is the air pressure sensor, oil sensor, all those different kinds of control. So whatever is the electronic control unit, ECU. Okay, so that you can say is a vehicle controller. So this is actually the master microcontroller that is there, and this is ABS controller and actuator. So ABS is nothing but that anti-lock braking system. Okay, so the seminars will be having this as a one of the main topic, ABS. So one or two groups would be talking about ABS also. What are the different sensors you can find? There's a speed sensor, there's a pressure sensor, that means how much pressure is given on the brake. Then brake pedal is there, the brake pedal position sensor is there, and beside the brake pedal position sensor there is a master cylinder or booster. So this thing is filled with oil, if as this is oil brake, so that hydraulic brake is there. So we are pressing this brake pedal, and that whatever energy we are pressing it with, this is actually getting amplified. And we have already seen the videos of these things previously. And from this master cylinder, actually the command is going to all the four wheels. Okay, front wheel, rear wheel, and all these things. Generally we say that front wheels are having disc brake and rear wheels are having drum brake. Whenever there is disc brake, there is a caliper kind of thing, brake caliper kind of thing. There may be a system where all the four wheels are disc brakes. So in that case, caliper will be there in all the four wheels. So likewise, so there's a master cylinder and booster. It is filled with oil, brake oil. So ABS controller, actuator is there, vehicle coordinator. controller, axle, brake plate, brake caliper. So everything is there. So all these things actually we have studied previously. Let us see some feature. So the mechanical brake system consists of master cylinder and booster, which is shown here. Okay, so it may or may not have ABS controller and actuator, but has a brake caliper and brake discs. So brake caliper, brake disc you can find on this. Okay, so there is a disc connected with the wheel. As soon as you are pressing the brake, so the caliper actually is pressing or holding the wheel. In that case, what we are finding is the deceleration is occurring, torque is reducing, and the car is coming to a halt. Okay. So the ABS might be there, might not be there, but the brake caliper and brake discs are always there. Electrically, motor directly applies its braking torque to the front axle and is controlled by the vehicle controller based on the vehicle speed and brake pedal position. So depending on how much pressure you are giving to the brake pedal, depending on that, the ECU or the vehicle controller decides that how much brake has to be applied on each of the wheels. Okay, so accordingly this calibrates and the brake amount is controlled. So the signals are actually produced from the position sensor, pressure sensor, speed sensor. The signals represent the desired braking strength and braking control strategy embedded in the vehicle controller. The feature of this parallel hybrid braking system, so this is the main thing. So this is the same parallel hybrid braking we are discussing now. Feature of the parallel hybrid brake system is only the electric braking force or torque is electronically controlled. Okay, so here parallel hybrid brake system, only the electric braking force is electronically controlled, but the mechanical braking force is controlled by the driver through the brake pedal before the ABS starts its function. So ABS is something which is actually it is a controlled by the microcontroller and all these things. So it is a kind of a smart control. So in parallel hybrid brake systems, we are finding there are mainly two controls in the brake. One is electronic control, another is mechanical control. So electronic control torque is electronically controlled. That means whatever ABS and other things are there, that is controlling it. And mechanical control is actually done by the driver himself. Okay. And ABS is there. If ABS is there, it's an anti-lock braking system. That actually saves the car from the lateral all kind of different kind of deviation which are there. It saves it from that. So the tire should not get jammed. Okay, and even if the tire is getting jammed, it should not skid. Okay, that is actually that part is actually stopped or taken care by ABS system. Tire should not skid. As soon as we put brake, it's in a very huge amount of velocity. As soon as we put brake, the vehicle should not skid. Okay, so that part is actually stopped by the ABS system. And what is the traction control TRC does? If the road is very much slippery, in that case what happens, the tire is continuously rotating but there is no proper contact between the tire and the road. So it happens that the tire is rotating but vehicle is not going forward, so there is occurring some kind of slip. So TRC or traction control actually helps to avoid that part. So ABS and TRC, very clearly you should understand that ABS is helping the car not to skid after it brakes. And second thing, TRC, traction control, generally happens where snow and all these things are there. So whenever the car is trying to rotate or trying to generate some tractive kind of a force, and if there is snow, what happens is the tire actually keeps on rotating and the slip happens and the car vehicle does not go fast, or the vehicle does not go ahead. In that case, the TRC system comes and it checks that part. That is, vehicle should go forward, tractive force should be used properly, and all those things. So the mechanical brake force is controlled by the ABS when the wheels are about to be locked. Wheels are about to be locked means it is going to experience a brake, and after that it should not skid. Okay, so that is the job of mainly ABS. As in conventional brake system, the key problem in the design and control of such a system is to properly control the electric braking force to recover as much braking energy as possible. That means we don't get much of regenerative braking from this parallel hybrid brake system. That's why you should go for the second type, which is called as fully controlled hybrid brake system. And this is called as HEBS. Okay, HEBS or HEBS it is called. So this is hydraulic electric brake system. That is the full form. And this is more of a smarter control you can find. So previous case, whatever ABS was there, it could be there, it could not be there. But in the case of HEBS, ABS and all other thing are already installed. That is anti-lock braking system, traction control, all these things are there. So in recent years, more advanced braking systems have emerged that allow one to control the braking force on each wheel independently. So this HEVA system is actually taking care of the brake on every wheel separately. That means this is the central unit, HEBS or ERB. Okay, so this unit is actually, you can see there are so many inputs, 1 2 3 4 5 6 7. So there are 7 inputs which are coming, okay, to this HERB. So they're all sensed inputs, and it is not only sensing. So previous case there was a pedal sensor, there was a speed sensor, there was a tire position sensor, that's all. In this case you are finding that brake pedal position sensor is there, brake pedal is there, master cylinder is there. So all these things are there. Apart from that, there is a pressure sensor. Okay, in the line means the tubes inside which the fluid is there, brake fluid. Okay, so inside that, how much is the pressure should be high, okay, for proper braking. So that pressure sensor inside the tubes, that is the line, power line, brake line, it is being checked continuously. Speed sensor was there previously, brake plate is there. So this is a tire, on this the brake plate is there. Okay, actually this plate is being held by the brake caliper. So as soon as we are giving the signal of brake, it is generated at the brake pedal position and it is going to the tire. Okay, this caliper actually holds this brake plate. Okay, so there are 3-port switch. This is a new thing. This is a new thing. So there's a 3-port switch. What is the job of it? We will explain shortly. Then there is electrically powered brake actuator, motor drive, and transmission. So this is an integral part of regenerative braking. Okay, so electrically powered brake actuator, motor drive, and transmission. So there's a new part, and there's a energy storage. So previous case also energy storage was there. So after regeneration, all this energy coming, and it is actually fueling the energy storage part. And this is the heart actually, HEBS and ERB controller. And then there is a fluid accumulator. So there's a fluid accumulator, and this is the there's a 3-port switch. So these two are the main heart of this HEBS system. And apart from that, everything else is kind of a similar. So the difference between the previous, that is the parallel hybrid brake system, and present fully controlled hybrid brake system, main thing is this HEBS or hybrid hydraulic electric brake system. This is the controller. Second thing is this thing, there is a 3-port switch. Third thing is the fluid accumulator. Okay, so these three are the main differences between the previous and present a fully controlled HEBS system. So fully controlled hydraulic brake system consists of hydraulic electric brake and electric regenerative brake. Okay, so previous case the regeneration was not very good. This is a modern system, that is HEBS system. Here regenerative brake is the main agenda. So mechanical brake system consists mainly of a brake pedal and its position sensor, a master cylinder, and electrically operated and controlled brake actuator. Electrically controlled 3-port switch. So this 3-port switch is actually electrically controlled. This is actually ensuring how much would be the pressure, how much would be the fluid going inside the lines and other things. So that is actually controlled by this 3-port switch. So fluid accumulator is there. This is also another change. So this is also this fluid accumulator and switch. They are actually controlling the pressure and fluid flow inside the brake lines. So, and a pressure sensor. So pressure sensor is there at every stage. So previously pressure sensor was there only at brake pedal. Now the pressure sensor is there through in every brake line. Okay, wherever the fluid is there, everywhere the pressure sensor is there. So it consists of pressure sensor in normal operation. The port 1 and 3 of the 3-port switch are open and port 2 is closed. So open and close of this switch ports are actually controlled by this HEBS, and depending on that it can control the fluid flow or the brake fluid flow towards every tire. So that can be increased, decreased depending on the requirement. So the main difference is every wheel in this case is controlled or checked separately. So in HEBS system, every wheel is controlled separately. Whether in the previous system, that is a parallel hybrid brake system, generally front 2 wheels are controlled in one way, the rear 2 wheels are controlled in one way. But in case of fully controlled hybrid brake system, every wheel is controlled separately. So that much better control or specific control is designed in case of HEBS system. The torque command. So it's a very important paragraph. The top one, the short questions can be asked on this. Please prepare. The torque command to each wheel is generated in HEBS system. So that is the main feature of a fully controlled hybrid brake system. So based on the pressure signals from, so these are the signal generators. Okay, so how many signals are generated here in case of fully controlled hybrid brake system? Number one, pressure sensor. So pressure sensor may be pressure sensors in the line. Okay, so this is a pressure sensor in the line. This is actually sensing how much is the pressure in the wheel, sorry, how much is the pressure in the line. So that thing is sensed regularly. The brake pedal stroke signal from the brake pedal position sensor. So how much pressure is given on the brake pedal, that is sensed. Number three is wheel speed signal by speed sensor. So what is the speed of the wheel? Because how much brake pressure has to be applied that depends on how much is the present speed of the wheel. So car is going very slow, in that case maybe we need a small amount of brake pressure, but when the car is at high speed, to bring it to decelerate it, we might require higher amount of brake pressure. And number four is the embedded control rule in the HEVS controller. So we have not studied this adaptive controller or PID controller and all. So depending on the error signal generated, what is error signal? How much speed we want. Okay, suppose we want a lesser speed, and how much speed is there actually on the vehicle now. So depending on the current speed and depending on the required lesser speed, the control algorithm will generate how much brake has to be applied automatically. So there's a in the automatic car, all these things happens. So there are mainly four signals which are continuously being put in the HEBS or ERV controller. First one is pressure sensor in the line. So whatever brake lines are there, whatever fluid is there, how much is the pressure of the fluid. Second is the brake pedal stroke signal from the brake pedal position sensor. Third one is the wheel speed signal by speed sensor, and fourth one is the embedded control rule. So that embedded control rule is actually here in this HUBS. Okay, so how much or what kind of dynamics is there, the relationship is there between the input signal and output brake arrangement, all those PID, adaptive control and all those things are there. Okay, some, so AI, ML and all those things you can apply here also. So that control rule is there in HEBS controller. So the mechanical braking torque applied on each wheel is independently produced by the corresponding brake actuator, which is commanded by the HEBS controller. So I told you that between controller and the actual process, there is something which is called as an actuator. Controller generates a signal and process is actually analog. So controller might generate a digital signal because all this controllers and everything is a digital thing. So after that there is a DAC. So the DAC converts the digital control signal into equivalent analog signal. Then there is an actuator. So actuator takes the converted analog signal into its input, and actuator changes its position, and the signal from actuator goes to the actual vehicle, and actual vehicle changes its performance accordingly, whatever control is received from the digital controller. So this HEBS ERV controller can be a digital controller, and whenever there is a caliper, so this can be an actuator. So between this controller and actuator, okay, so there might be a ADC, DAC, digital to analog controller, and this caliper is actually also, this brake caliper is actually holding the disc, and that is actually offering the deceleration on the wheel, and that is actually creating the mechanical brake. So the mechanical brake torque on each wheel, that's very important, each of the four wheels is independently produced by the corresponding brake actuator, which is commanded by the HEBS controller. So there are actually four calipers, one on each wheel. Brake fluid from master cylinder flows into the fluid accumulator through the 3-port switches. So this 3-port switch actually is controlling how much fluid will be entering the fluid accumulator. Okay, so this is again another control, and which is controlled by this thing, HEBS system. So 3-port switch to exert pressure to emulate the braking feeling of a conventional brake system. Okay, so from the master cylinder, so this is the master cylinder inside which all the fuels and all these things are stored. So this HEBS is controlling the master cylinder also. So this brake fluid actually it is controlled by 3 switches to exert pressure and emulate the braking feeling of a conventional brake system. So in the case of failure in any brake actuator, the corresponding 3-port switch switches to the mode of port 1 and port 2 open and 3 close. Brake fluid from the master cylinder goes directly to the brake caliper cylinder and thereby maintains the braking torque. So actually this HEBS is actually giving the fluid to this accumulator through this 3-port switch. Okay, and every stage there is a sensor and every wheel is controlled separately, but sometimes suppose if there is a failure, okay, in any of the actuator, so whichever actuator is actually causing the brake to happen, so if there is any failure of the actuator, then there is a direct kind of a control. Okay, so in that case this 3-way switch, 3-port switch and all these things, accumulator, fluid accumulator, all these things are bypassed. So in that case whatever was happening in the previous case, In the previous case means whatever we have seen in case of parallel hybrid brake system. So in this case, all this 3-port switch, all the fluid accumulator, all those things were not there. So okay, so this 3-port switch accumulator, they are more like a sophisticated kind of a system. But if there is a failure of the any brake actuator, in that case, that parallel whatever brake system is there, that kind of system is again coming into the picture. So these are the two braking system. First one was the parallel hybrid brake system. Second is the HEBS or fully controlled hybrid brake system. So together, these are the mainly brake systems which you are finding in case of EV, HEV or FCV. That is a fuel cell vehicle as well. So in regenerative braking, the main features. So the main feature we have to remember in regenerative braking is an electric regenerative brake mainly includes an electric motor and its controller. So motor and its controller means who is actually driving the motor. Okay, and an onboard energy storage. So there are mainly three parts in regenerative braking. First one is the motor. Second is who is driving it, so drive for the motor, and third one is the onboard energy storage. That is the battery. So the whole motor drive system and the battery. So this is the main part of regenerative braking. ERB controller is used to control the electric braking. That is the electrical braking system is controlling the electric energy, regenerative energy. Based on the wheel speed, brake pedals, stroke, charge condition in the energy storage and control rules embedded in the controller. So just explained in the previous slide. The second point is one of the key problem. Okay, so at the end of this regenerative braking, they are talking about the limitation of the system. So one of the key problem in this system is how to control the mechanical and electrical braking torques to acceptable braking performance and recover as much available regenerative braking as possible. That means there has to be some kind of understanding, or there can be some kind of trade-off between mechanical braking as well as regenerative braking. So mechanical braking is actually put to decelerate the vehicle, and actually mechanical braking is offering us safety. Okay, and regenerative braking is offering us energy. So there should be always a balance. So recover as much available braking energy as possible. This is the agenda, but this is not the agenda for safety. This is an agenda for increasing efficiency. Okay, so two typical control strategies introduced in this session are, so previously whatever we have explained, so it had two main strategies. Number one was it emphasized the braking performance, that is the mechanical part of it, which ensures safety. And number two is maximizes the regenerative braking energy recovery. So whenever regenerative braking is asked, so two things you have to point out. First one is how to ensure safety, how to ensure the deceleration, how to bring back the car into rest if there is a overspeeding. That is actually done by the mechanical braking. And second part is how to maximize the regenerative braking so that we can recover maximum energy that is wasted during the braking. So these two are the main agendas which is explained in case of regenerative braking. So 2 days we have given, we have missed Saturday's lecture, that will compensate in this week. We'll do that. So this is the end of module 3, but one topic is still remaining. We will have a short discussion on it, what to write and from where to write, because 6 links I have posted to you, 6 or 7 links. In one link, which is having 3 lectures. So it's a series of 3 lectures from MATLAB. Okay, so those 3 lectures, if you listen, there is nothing more we can talk about battery management system at your level. And yesterday we have found out another thing, that is there's a PDF, so that I'll upload with this lecture today itself. It's a 29-page PDF, and it is actually prepared by Dr. Gregory L. Plett. He is from University of Colorado, and these links are given. So the PDF can be found out here. I'll upload the PDF, so you don't need to even click on this link. The PDF will be available to you. This link you can click because this is the course page of Dr. Plett, and you can find out this kind of a page there, and there you will find out chapter 2, so ENC model of toolbox and Python based ESC model. So whatever SOC and other things control all these things in battery, that can be found out in chapter 2, chapter 4, chapter 6, and 1.2 GB is there. So software is given. You can do this battery bootcamp, equivalent circuit cell model, Microsoft cell model, microscale cell model, continuous porous electrode cell model, state space model of discrete time, realization algorithm. All these things you can find out in this. So it's a this website is given also at the top, that is mocha java uccs University of Colorado Spring. Okay, so that is uccs edu bms is battery management system 1, and the name of the professor is Dr. Gregory L. Lect. Okay, so this page you can go and you can find out there are many projects which are already available. So those who are working with this renewable energy group, those who are working in the field of electric vehicle design, and if you want to work in the field of BMS and you want some Python coding and some support, all those things you can find in this website of Dr. Gregory L. Platt. So all these links and other things. So 3 links I have mentioned. The first link is for PDF, second link in for this page, course page, and third link is for ahead of it. So there is another page it will open. So all these things I'll be posting today. You can go into the depth of a battery management system with it. Okay, so I'm not finishing this lecture. What I'll do is whatever is the PDF uploaded by Dr. Plett, that we will see. So what we are going to see now is I will upload a window with the PDF that we are finding from Dr. Plett. Okay, so just give me some time. I will upload it, and again I'll come back. So just give me 1 minute time. So it's a 29-page PDF by Dr. Plett, and he has explained extensively. So battery management system is nothing but an embedded system kind of thing. So it is all in our domain, and you people are doing quite a lot of things in the field of advanced embedded system and other thing. So what all things to look for, what all parameters to check in a battery, that will be actually helping the enhancement of the management of the battery or efficiency of the battery. All those things are explained in this BMS thing. So I have uploaded the slide. I am presenting the slide. The same thing will be given to you. This is not a slide actually. This is a PDF, and it is quite an effective PDF. So I'll be increasing it up to 80% or so, and you can just go through, and the questions that will be asked from battery management system, that also I will upload. Also I will upload all the question bank for this third module. So I told you that fourth and fifth module are comparatively less exhaustive. So this till this third module the topics were quite big, topics were quite exhaustive. Fourth and fifth module, it is kind of a straightforward. Okay, so not much we have to study. It is kind of smaller modules. So what to read actually from this 29 pages, and what all to prepare from this 29 pages for exam, that I will let you know by 1 or 2 questions that will be set from this battery management system. So this battery management system you will not find in ASANI directly, but there are a lot of websites. I have already shown you some 6-7 links there you can find out. But yes, for writing in the exam you need some constructive material. So that material you can take from here. So the questions will be set keeping this PDF in mind, and I will send you the questions. And the OBA questions will be uploaded today. So both the OBS you have to write down as soon as possible, and by this week you complete your OBA 1 and OBA 2. So next week onwards we will be having seminars, and send me the group names. So 2 names and their USN have to be sent to me in WhatsApp group as soon as possible. So I'm giving you 1 or 2 days time. So today is Tuesday. By Thursday morning, the name should come to me. Otherwise, I will make the students group, and I will give the topic, and the presentation will happen from next week. And the presentation will happen in the extra time, in the evening time or so. So the whole group has to talk about some 15-20 minutes, half an hour, and there will be question answer sessions, and we'll finish all the 42 seminars as soon as possible. So battery management system requirements. So battery management system for other application is different, and battery management system for vehicle, that is electric vehicle, that thing is different. So here they have kept electric vehicle only in their mind, but yes, other battery management system for other applications are also discussed here somewhat. So introduction to BMS functionality. So what all things that we are supposed to track by using the embedded system, that is first explained here. So the course investigates. So Mr. Plett or Dr. Plett, he has He is running actually a very famous BMS course. You can go through that. You can go through the course content and everything. The course investigates the proper management and control of battery packs. So it's not only one battery, it's a huge amount of battery pack, usually comprising many cells. The methods, so you can find here, there's a battery management system and all the cards and hardwares and all these things are there. So the methods and algorithms that is discussed here would be typically implemented by a BMS system. So the BMS is an embedded system. So purpose built electronic plus processing to enable a specific application. So this is the definition of BMS. So it's a nothing but a tracking system or all performance, battery performance tracking system. What all things it does? So this is what all acts the BMS do. Okay, so this can be a question for 5 marks. What are the different acts of BMS? So it protects the safety of the battery operated devices operator. Okay, so it protects the operator, protects the device as well, protects the battery as well. Because if battery blasts, it is not only the battery which is damaged, the car will get damaged, it will cause accident, the driver will get damaged. So through BMS, we are actually first safeguarding the battery, second we are safeguarding the car, and third we are safeguarding the driver. So all these things are actually put into a safe measure. So it detects unsafe operating conditions and responds. So sometimes the battery blast. We have seen for Samsung mobile also battery blast. So before it blasts, it gives some indication because we have to fit some sensor in BMS. Okay. So detects unsafe operating condition and response. So protects cell of battery from damage in abuse or failure cases. So battery is a big unit and this is having some many small cells. Okay. So it protects each and every cell of the battery from damage in abuse or failure cases. Abuse means too much of exhaustive use of the battery. That is actually called as abuse. So it can give us 5 ampere current, but we are asking for 50 ampere currents from it. So we are actually stretching the battery for more and more performance. So that can be actually called as the abuse. Okay. So it prolongs the life of battery, normal operating cases. It maintains battery in a state in which it can fulfill its functional design requirements. So battery life is prolonged, maintains the battery in a state in which it can fulfill its all functional design requirements. So it informs the application controller how to make the best use of the pack right now. That is power limits, control charger, etc. So always there is a strategy, always there is a kind of a optimized performance, always there is a criteria or algorithm which is going on in battery life enhancement, battery efficiency enhancement. Okay, and this is a smart strategy. So already all artificial intelligence, machine learning, all those things are there in case of BMS. And BMS is one thing which can maximize, okay, the operation or operating range of the vehicle, because battery is the heart of the vehicle, battery is the heart of the vehicle, and there is a mind. Okay, mind is nothing but the controller. So that controller is supposed to control the heart in such a way that it is exerting least amount of energy and it is going most amount of distance. So that is what battery management system is supposed to do, that is waste least amount of or use least amount of energy and cover biggest distance whichever is possible. So there is a cost associated with battery management. Cost does not always means money. Okay, cost means performance cost. That means you are getting some performance at the cost of what? So every time the battery is charged or discharged, its lifetime is reducing. That we have to remember. So for every charge or discharge, how much to charge, how much to discharge, whether to discharge it completely, whether to charge it completely, all those things depends. And we have seen in this module only that we have to take the battery charging up to maximum 50 to 60%, and we have to discharge it to again another maybe 20 or 30%. So you should not charge the battery up to 100% and discharge it to 0%. That is too much of cycling. Okay, so all the smart strategies has to be designed here. So there's a cost associated with the battery management. So not all applications implement all features. So definitely for every vehicle we cannot apply all the strategies for efficiency enhancement, but yes, for certain vehicles we can apply some strategy, because every vehicle is having its different agendas. Whenever we are talking a vehicle of Formula 1, in that case the strategy is different. If we are talking about a vehicle like big SUVs of BMW and all these things, in that case too much power is required. Okay, we should always run at the speed of 200 250 kilometer per hour. In that case, the battery management strategy is different. And for smaller car, okay, which are used inside the city, sabzi bhaji lane ke liye jo car use hota hai, for that battery will be having a different strategy. So there's a cost associated with the battery. So not all applications implement all the features. Your battery is cheap enough. A very big line given at the end. The battery is cheap enough if you cannot remember the last time you replaced it. That means we have replaced the battery and we have forgotten. That means battery is giving us very good performance over many years. In that case, this is the best battery management system. Unknowingly, the BMS is very good in that case. So we have replaced our battery and we forgot when we had replaced the battery. If that is the case, we can say that the BMS in that vehicle is very good. Okay, so it is silently, it is doing its job, and it is giving the best optimization of power, and it is managing the battery in the best possible way. Larger battery packs represent greater investment and motivate better battery management. So sometimes we invest a lot of money on battery, but we don't invest too much money, or we don't use a smarter technique. So even if the battery is good, but we don't get a good efficiency or good utilization from the battery, and bad utilization actually reduces the lifetime of the battery. So good battery, highly efficient battery is very important, and a better management strategy for the battery is more important than that. So sometimes a student can be a mediocre student. Okay, a student can be a mediocre, so he's like the battery, but a good teacher or a good mentor can extract best out of him. So it is exactly like that. With good student and good teacher, tremendous result can be obtained. It's okay, that's understood. But not every body or not every person, not every car can afford world class standard battery. So it can use a mediocre battery. But yes, control strategy is in our hand. Control strategy is designed by the engineers. Control strategy is designed by using a microcontroller. So a mediocre battery, but with a very smart control. Okay, that will give us a very good BMS, and which will increase the efficiency of the car, which will increase the lifetime of the battery. And as the lifetime is increasing, the total cost of energy for the battery will keep on reducing. So huge amount of work is going on in BMS, and huge amount of work will keep on happening in BMS. So in another 10-15 years, there is always a market for BMS. So those who are taking that ML related core elective in semester 6, previous semester also you might have taken, this semester also you have taken, so machine learning, deep learning, all those things, artificial intelligence, all those knowledge there. So those are tools, and this is the application field. If you can club them, huge field or huge research prospect you can have in your life. So battery management system by using ML or DL. So that can be a very good study. So I'm actually talking about the field, application field, and those are the tools you are learning in the other elective. So please do that also very properly. And first we have known what is a battery, what all parameters can be controlled, and then apply all the strategies learned in MLDL to control the battery here. Okay, to increase its performance, to increase its lifetime, to reduce its cost, all those things. So vehicular application include hybrid electric vehicle, HEV. So motive power. Motive power means the thing that creates a motion, okay, or tractive power we call it. Motive power provided by battery plus at least one other source, because in this case we are talking about HEV. So essentially zero all electric vehicle range. Okay, plug-in hybrid electric vehicle. So larger battery than HEV. So this is another second type, PHEV, extended range. So it is called as EREV. But mainly we are concentrating our knowledge on or study on HEV and EV. So EV is electric battery vehicle, or BEV, battery electric vehicle. Only battery provides the motive power. So BMS can be applied for EV, BMS can be applied for HEV. So PHEV and EREV also you can take, and different kinds of vehicles are already given who are using this battery management system. All these vehicles types employ battery packs that are large, high voltage and high current. Okay, so they are actually using high voltage, large battery, high current. Some distinction in design which we will detail when necessary. So they have done it later on. Commonality is more significant than differences. When distinctions aren't important, we refer to the whole class as XEV. Okay, so they are kind of a special category of vehicle. Another range scale application that justified advanced battery management is for grid storage and backup. Okay, So grid storage and backup also is explained later on. Battery pack topology. Okay, so what is the topology when many batteries? So we have seen in case of Tesla 3. Okay, if you see the battery, how the battery is thing. So very small kind of batteries of 3.5 volt or something. It is put like a bed, and on that, on the chassis only, it is put, and above that, all the designs and all this thing is there. So it is not a single battery pack. It is not like that. Very small battery packs, they are laid first, and on that, on the chassis, and after that, other designs and all these things are made. So that is called actually battery pack topology, how all the batteries are connected. So you can see here 96 cell groups PCMs in series. Likewise, okay, so 96 cell in series. Likewise, so here 3 cell group SCMS in parallel, so 3 parallel cells. So here there are 3 parallel cells, here 3 cells in series, and all the things are in parallel. So many different kind of topologies. Topology means how the batteries are connected to each other to give the net output voltage plus minus across these 2 points. That is actually is discussed in this. So you can just go through what are the different topologies. So it is called parallel cell mode PCM, it is called a series cell mode SCM. Okay, so 3P6S has 18 cells, 3 in parallel and 6 in series. So this line 3P6S, 3 in parallel and 6 in series. Then modular power and energy both approximately 18 into that of a single cell, but not quite. So 18 cells can be arranged in 3P6S in module and all those things. So that is about topology. So all the things that you can study. First one is topology, how the batteries are arranged. Second is BMS functionality. So here comes our main job. So whenever you're talking about BMS, this is the main BMS thing. It is interconnected with all battery pack components and with vehicles that controls the computer. So here all the cells stand here. So this is the topology we have studied. Then there is the BMS. So BMS is at the center of it. What all things it controls. So it is actually checking how much is the state of charge, how much is the charge remaining, what is the rate of charge at which the battery is getting discharged, all those things. So inside this there should be a cooling system. So whenever there is a cooling system, there will be a lot of temperature sensors, and there will be a lot of coolant and all these things passing. It can be air cooling, it can be oil cooling, it can be water cooled system. So their temperature, their inflow, their outflow, all the things has to be sensed and controlled. Vehicle control computer. So vehicle control computer is the ECU, or electric control unit. So that is actually controlling the BMS. So it can be a master slave kind of a thing. They are connected by CAN protocol. So CAN protocol is another thing you can check. Okay, so vehicles are controlled by CAN protocol inside the vehicle. All these instruments are controlled by CAN protocol. So this is the main thing, vehicle computer control. This is the main ECU, and this is having a slave kind of a microcontroller. So this is a master vehicle ECU, and there is the slave battery management system. There is another controller is there. So this is a local control. Okay, and vehicle computer control is actually a global control inside the vehicle. So BMS is interconnected with all battery pack components, and with the vehicle control computer, functionality can be broken into. So this can be a big question. What are the functionalities of BMS? Sensing and high voltage control. What all things are measured, control you can check. Protection against over voltage, over discharge, overcharge, overcurrent, short circuit, extreme temperature. So these are protection things, and everywhere there is a sensor involved. Third thing, what is the interface? Interface is range estimation, communications, data recording, reporting. Range estimation means whatever charge is remaining with that, how far the vehicle can proceed. Okay, and communications between all the different you can say what all different hardwares are there inside the vehicle, communicating with that, and communicating maybe with the other VANET. So you might have heard of VANET, that is vehicle ad hoc network. So there may be a lot of vehicles together, they might be creating a network. So it's a dynamic kind of a network. So their communication might be used. So your vehicle is actually talking to the other vehicle, and through communications and all. Okay, so for that also energy is required, and that energy with other car, with inside this vehicle, how the communication is taking place, how much communication has to be done. Okay, so all those things, data recording, reporting. So they are mainly the interface part. Performance management, state of charge. So SOC, we have studied what is SOC, what is the definition of SOC. Power limit computation, balance and equalize cells. So this is the main important part, performance management. And diagnostics. Abuse detection. Abuse detection means I told you that if it's a 5 ampere battery and you are asking for 50 ampere from it, you are actually over stressing the battery. Okay, that is actually abuse. State of health estimation, so SOC actually falls in SOH only. State of life estimation, so here all these things are explained separately. So battery pack sensing, this is the voltage, how the battery pack sensing is done. So one or two we can say. Temperature sensing, so whatever parameters they have explained previously, sensing of all of them, okay, is explained in detail. So battery sensing and temperature sensing, these are the two main part in the battery management system. And as you found in case of that extra lecture that we had kept, guest lecture, so she had explained that this thermal runaway should not happen, because once the batteries start getting heated up, its efficiency continuously decreases and decreases very fast. Okay, so that thing should not happen. So battery pack sensing, current sensing, over discharge sensing, all those things are there. So such many parameters. What is Hall effect sensor? So that is a very important thing. So high voltage contactor and control. What is Hall effect sensor? Hall effect based sensing. All these things are explained. So this is a document I will upload for you, and just go through this document, and whatever questions I ask from it, try to find out in this from where you can prepare. So question will be asked from this document in your final exam, in your IA, in your OBA, because battery management system is one of the most important thing. And lastly, they have told that where from here. So this is a very important thing. This is the last page, page number 29. Where from here means whatever things they have explained from there, where all can you go? So what is the research scope or future research direction? That is actually explained here. So the focus of the rest of the course is how to estimate the battery internal state, how to control the battery operation for optimal trade-off between life and performance. So too much extraction of energy, too much pressing the battery with too much of extractable current is actually reducing the battery life. So how much to press so that the battery life also does not get damaged and battery give the maximum efficiency? That is actually the main question. So I stop here. I am declaring the module number 3. This was the last topic. Please go through